Here we have this figure that's really just a composition of two triangles to form a quadrilateral, and we're asked to find all the possible values for x. Cool. So first off, we should check to see what the relationship between these two triangles might be. They do have a shared side, so I'm going to mark that as congruent in both triangles. And with this, they clearly are not congruent because they have these two sides that aren't congruent. But we did learn those new triangle inequality pieces, and that is that if these two legs here are congruent and then we have an angle in between them, we kind of have a side angle side inequality. And what that's saying is that if the 15 here is greater than the 10, then the angles that they are opposite of, the 60 degrees, and in this case an expression, 5x minus 20 degrees, well, they have to have the same relationship. And if this opening here is bigger, then the angle here must be bigger as well. And if this opening here is smaller, then this angle must be smaller. So I have that relationship here, which allows us to solve for x. And I'm going to use my test interval method, meaning that here we're trying to figure out when these are different. First, what we're going to do is we're going to figure out when they're the same. And that gives me two possibilities. X either has to be greater than 16 or x must be less than 16. All right, and so we'll go ahead and test this one here, and we're going to find that if we pick, for example, x equals 20 to test it, if I plug 20 in here, that's clearly going to be a lot bigger than 60, so this is clearly wrong. Now, one thing I want to caution you with is this one here, we're ignoring a specific or another constraint here, and that is that this angle has to be bigger than 0. I mean, there's no way that this angle could be 0 or negative and this still be a shape. So before we test the second value, let's look at what our other constraint might be. So again, I'll do the same thing. I'm going to test it out by first figuring out when they're the same. All right, so now this tells me that I have really two critical values. And so what I'm actually going to do here is I'm going to just plot those out here. And that means that I could either be in between these values, and I'm going to use open circles here because 4 and 16 would make it equal to 60 degrees or make it equal to 0. And again, these are not greater than or equal to signs. And the thing is here that just looking at this figure, it's pretty clear that it's going to be in the middle. So I'm going to go ahead and just test this with 10, and I'll plug that into both of these real quick. So I get 50 minus 20. 50 minus 20 is less than 60, so I'm good there. And I'm going to do the same thing here, and I get 50 minus 20 again, and I'm going, or of course I do, and of course that is greater than 0. So yeah, this is where my solutions are going to lie. So I want all the x values that are greater than 4 but less than 16. I would point out that the method I'm using here is pretty consistent. It is a little slower, and of course with all of these you're going to have to be careful that you don't miss the fact that there are two conditions here. One, that it had to be smaller than the angle 60 degrees, but then obviously it needed to be bigger than 0 degrees as well. We can't have a negative angle or even a 0 degree angle and have this still be a triangle.